Yes, Bonita, go ahead. You can unmute and you pray for us.
Let's humble ourselves for a word of prayer. Heavenly Father, I want to thank you so much for this day. We thank you for the gift of life. We thank you, God, that you have guided us and protected us. Father, I pray as we enter this lesson, Father, may you enable us to pay attention. May we understand what the teacher is teaching. In your mighty name, I've prayed and believed. Amen.
Amen. Thank you so much, Bonita, for that beautiful prayer. Okay, so last time with Mr. Anshuna,
Amen.
some of these equations, and I think if someone can remind me, I think we stopped at this equation, the one of potassium. We stopped last week. Sorry, a month. Girls, are you able to hear me?
No,
No.
no, we can hear you, but you're not loud enough.
Okay, but I'm wondering how you heard that I asked that question, whether you're hearing me. Okay, am I clear now?
Yeah.
Yes.
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 Okay. So, were we able to go through this equation to balance it? Were we able to balance it?
Yes.
Okay, who is that? Maybe you can take us through.
It's Amelia.
Okay, please take us through how you did it.
We have two. We have potassium and chlorine and oxygen. Then that is the reactant side. Then on the product side, we have still potassium, chlorine plus oxygen also. So what I did was I separated them, chlorine and oxygen. Then I first finished.
Okay. How many potassium
And
did you have
oxygen.
inside? Okay.
One. I had
then
one
chlorine?
potassium, one chlorine,
Okay.
and then oxygen is 3.
Okay. And then on the product side?
Then on the product side, I have one potassium, one chlorine, and 2 oxygen atoms.
Okay. What did you do next?
What I did first was to put 3 before oxygen on the product side.
Why did you put a 3?
So that I get to get 6. I just did it to get 6, and then I just put 3 so that I get 6 atoms here, and then I went to the reactant side. I put 2 before this molecule of chlorine and potassium and oxygen, so that 2 affects the oxygen, like makes the oxygen atoms stick also. Then since these 2 affects potassium and chlorine also, there will be 2 atoms of potassium and 2 atoms of chlorine on the reactant side. So to make it equal, to balance it also on the product side, I just put a 2 also before chlorine and potassium on the product side.
This side.
Yes.
Okay.
And that way, and that way we have two chlorine atoms and 2 potassium atoms. That is how I balanced it.
Okay. All right. Amelia, before you go, this is called potassium
can't hear
chloride.
you.
It's not red. You can't hear me?
Never mind,
You're
your
breaking.
signal is good. It's okay, it's just unstable sometimes.
Oh, okay. Sorry about that. So I was saying that this compound is called potassium chloride, not potassium, chlorine, and oxygen. Is that okay?
Yes, teacher. Thank you, teacher.
Okay. You're welcome. So, Mary, I wanted to ask you that the process you went through to know that you had to add a 3 here, because there are some people that have been following through and they need to know why you chose to add a 3 here. Because when we look at the comparison, this left-hand side and the right-hand side, you notice that there is an imbalance in the oxygen atoms. We have 3 this side and we have 2 this side. So that means for our equation to be balanced, we need to have the same number of atoms on either side. So if you don't mind, if you can take us through how you came up with those values. Or even we can get someone else. But Mary, are you taking us through?
Yes, teacher.
Okay, please.
So I just thought that why I thought of 3 was because, okay, if you try to use 1, and we put,
Okay.
I mean, we can't use 1 because 1 will still be the same. So, okay, let's start with 2. If I
Okay.
put 2 there, then it would be 2 times the 2 on this oxygen to give us 4. 4 on the other, on this side. So if it wouldn't make sense, because if I also put 2 on this side, on the compound of potassium chlorate, then it would make oxygen 6, and it still wouldn't be balanced. If I put 2 here, there would be 4, because here, since we have 2,
Okay.
there are 6 atoms of oxygen in this compound on the reactant side. So that determines what number to put before the oxygen on the product side. So if we start with 2, it will give us 4. Then if we try 3, we shall get 6. So I just tried that, and then that is how I got the number that I was supposed to use.
Okay, thank you so much, Amelia. That was good. So we said in balancing, we look at the number of atoms on either side. That's why I listed them. But with more practice, you notice that you will just figure out how to balance these equations. That is why we are doing several numbers to get there. So you notice that, as Amelia has told us, she thought that because atoms on this side and there are 2 oxygen atoms on this side, how can we make them have the same atoms on either sides? So you ask yourself, she first tried out with 2, for example. When you multiply to this side, it will give you 4 oxygen atoms, and when you
You're
give you 6
breaking.
oxygen atoms. And that means the equation will still be unbalanced. So you move to the next number, for example, 3. Okay, I hope I am now clear. Sorry, my name can pick something today.
Teacher,
Okay,
please
so are you able to get
before.
me now?
Yes, teacher.
Yes, teacher.
Okay, I was saying that when we are balancing the equations, we are looking at the number of atoms on either sides of the equation. For example, the left-hand side, which we said is the reactant side, and the right-hand side, which is the product side. So when we are balancing them, we outline them so that we can be able to know how many atoms we have on either side for each element. And as Ameria has told us, we have 1 atom of potassium, 1 atom of chlorine, and 3 atoms of oxygen on the reactant side, which is the left-hand side. And then on the right-hand side, we have 1 atom of potassium, 1 atom of chlorine, and 2 atoms of oxygen. But we know that for us to balance our equation, those atoms should be the same on either sides. So we look at oxygen. When you look at oxygen, maybe I can rub this. Paula, your hand is up. Paula? Paula or Daniela, can one of you unmute and say something?
Yes,
Because
Miss.
your hands are up.
My
Yes.
internet connection is a bit shaky today, so I'm wondering, can you please put the recording in the Google Classroom?
Okay, I think Mr. Bato has had. He'll
And then, Miss, one more
help
thing.
us do the needful. Yes.
Please, may you re-explain this? I haven't understood.
Okay, that is what I'm doing, Paula. Just follow through.
Okay, thank you, Miss.
Welcome. Okay, I was saying that when you look on this side, we have 3 oxygen atoms. And when you look on the right-hand side, you have 2 oxygen atoms. But when you look at potassium, on the left and on the right, they are all 1. On chlorine, they are both 1. But when you look at oxygen, it is 3 and it is 2 here. So what comes to your mind? We need to balance these equations. But as Ameria told us, for example, if we try out by 1, if you multiply all these numbers by 1, they'll still remain the same. That means there will be no change. So we move to the next digit, maybe 2. So we try out with 2. We say that if we multiply this oxygen by 2, because we are looking at making this oxygen balanced, because it's the one that has different values on either by 2. And what you do this side, you make sure that you can able to do the other side. So if we add that 2 here, we'll have 2 oxygen atoms. And if we add that 2 here, we are just trying out. If we add that 2 here, we'll have 3 times 2, which will give us what? 6 oxygen atoms. And when you look at these oxygen atoms, are they really balanced?
No.
Maybe I can get a response from someone. You unmute and tell it's not
Miss,
going to
you're
help us balance this
breaking.
equation. So we move to the next digit, which is what? 3.
She's not breaking.
Okay, if we try out by 3, I can understand there are issues with network, but please bear with me. So we have 3. If we try out by 3, if we multiply this side by 3, we'll have 2 times 3, which will give us 6. And this side, we assume that if we added that 2 on this whole compound, we'll have 2 times 3, which will give us 6. And when you look at the oxygen atoms, you realize that they are balanced. But when you look at the potassium and chlorine, you notice this 2 wasn't there. You notice that they are imbalanced. They are not the same. We have 2 this side because we've added 2 on the whole compound. This 2 stands for everything that is here. So that means if we added the 2 there, that means we have to multiply by 2 that side, which gives us 2 atoms. And then this side also we have 2 chlorine atoms. But when you look at this side, you notice that the potassium and chlorine atoms are still 1. Can someone tell me what we do to these atoms to make them 2 as well, or to balance with the ones this side? You can unmute and submit.
We put a 2.
Yes, so we put it like that. Combine it with potassium, it becomes clear.
Yes, Miss.
Okay, so since there are no questions, I think we can move to the next example. Can I get someone to do with me this next example? Anyone?
I see Mwesigwa. Mwesigwa, can you go ahead?
Yeah, yes, Jemima.
Teacher,
Yes, Mwasibu.
can you hear me?
Yes, Jemima, I can hear you.
So we are going to first write the equation again. Yes.
Okay, Mwasibu, please go ahead.
Yes.
What do we do next?
So we first write magnesium and write magnesium is equal to 1.
Okay.
Hydrogen is equal to 1.
Okay.
Then the chloride is equal to 1.
Okay. Sorry.
Then on this side, this
Mhm.
right magnesium is equal to 1. Then hydrogen is equal to 2.
Hydrogen is equal to 2. Mhm.
Then chloride is equal to 2.
Okay. What do we do next?
Hydrogen chloride, you're going to put a 2.
We're going to put a 2.
Hydrogen chloride, we put a 2 in front.
Okay.
No, like
In front of it here.
the, yeah.
Mhm.
So we shall say on hydrogen chloride, 1 times 2 is equal to 2.
Okay.
And then on chloride, we also say 1 times 2 is equal to 2. Yeah, our equation is balanced.
Okay. Thank you, Jemima. Okay, so when we are balancing these equations, as we said, you list the reactants and then you list the atoms on the product side. And as you practice these equations, we say that this work, it may not be necessary as you keep on practicing, you find that you'll be able to know which number you can use to balance both atoms on either side. So in this case, we had hydrogen, we had one, and then chlorine. To this side of the product, you had magnesium as one, hydrogen as 2 atoms, and then chlorine as 2 atoms. So you notice that we need to balance the atoms this side, because you notice that magnesium was 1 atom on the right and 1 atom on the left. And then hydrogen was 1 atom on the left and 2 atoms on the right. And then the same for chlorine. You had 1 atom on the left and 1 atom and 2 atoms on the right. So this was to enable you find out how can we balance the ones this side. If there were 2 this side, we would easily find out that to make the hydrogen this side 2 atoms as well, what do we do? To make the chlorine atoms this side as well to be 2, what do we do? So we multiplied through by 2 and came up with a 2 on the hydrogen. You know that your equation is balanced. Any questions before we proceed to the next example? Anyone with a question?
Teacher Martha, I don't see any questions there. I don't see any hands up.
Seems all of us agree with Amelia.
You have
Let's move to
understood.
the next example. Can we? Okay, thank you, Teacher Silva. Okay, maybe we can get someone to do with me the next example.
Johanna?
Yes. So we have copper oxide. Is it copper? Yeah, copper oxide plus hydrogen chloride and gives us copper chloride. Yeah, and and water.
Okay.
So in the reactant side, we have 1 atom of 1 molecule of copper. Oh, yeah. And then we have 1 molecule of oxygen. Hydrogen, we also have 1. And fluoride, we have 1 as well.
Okay.
Then on the product side, we have 1 molecule of copper, 1 molecule of oxygen, 1 molecule of hydrogen. 2 molecules of hydrogen. And 2 molecules of chloride. And 2 molecules of chloride. So what I did, I put I put 4, to start it, I put 2 in front of copper oxide.
In front of copper oxide? Why did you put a 2?
Because I wanted to make, okay, I don't know the stages, but then my final answer required a 2 in front of copper oxide.
Okay.
And then I had 4 in front of hydrogen chloride.
4 in front of hydrogen chloride.
Then 2 in front of copper chloride as well. and 2 in front of water.
In front of water.
Yeah.
Okay.
So that on the reactant side would have 4 molecules of hydrogen and chloride.
4 molecules of hydrogen and chloride.
And on the product side would have 2 molecules. Oh, and also on the reactant side would also have 2 molecules of copper and oxygen.
Yes, please. Just a moment.
Make a correction before she continues to call these molecules. They're supposed to be atoms. Please call them atoms.
Okay.
They are atoms, yes. You can go ahead.
Thank you, Chasilvara.
On the reactant side, I had 2 atoms of copper and oxygen.
Okay.
And hydrogen, I had 4 atoms. And chloride as well.
Okay.
And also on this side, I had 2 atoms of copper and 2 atoms of oxygen.
Okay. Thank you, Johanna. Does everyone agree with Johanna?
No. I'm confused.
No.
So we are lost.
Very lost.
Okay, let's have one person speak.
Oh,
I
so I
saw
haven't
Jovia with a
understood.
very bold no. Jovia, can you take us through?
Yes, teacher. So just on like the original question, there are 2 atoms of chlorine on the right hand side and also 2 atoms of hydrogen. I think you just put the 2 in front of the hydrogen chloride to make them balance, because the copper atom is main one and also the oxygen is main one, and therefore balance.
Okay, Jovia, can you take me through using this space up here? This is on the left hand side. How many atoms do we have?
1 copper atom,
Mhm.
not 1 oxygen atom, then 1 hydrogen atom, then 1 atom.
Okay.
Then on the right hand, there are 1 copper atom, and 1 oxygen atom,
Mhm.
hydrogen atom, and also 2 chlorine atoms.
Okay. So what do we do?
I think you multiply 2 on chlorine and hydrogen.
And what do we get?
And therefore you put that 2 in front of the hydrogen chloride.
Where?
And therefore the equation is balanced.
Okay, thank you. Thank you, Jovia. Do we agree with Jovia?
Yes.
Yes, very well.
Yes.
Yes, teacher.
Okay, thank you girls for trying out the number, and thank you, Johanna, for leading us through this number. But you notice that when you're comparing in order to balance these equations, look out for those atoms that are not yet balanced, because when you look at copper and oxygen, you notice that on either side, there are 1 atoms on either side. Copper is 1 on the left, copper is 1 on the right. And then oxygen is 1 on the left, it is 1 on the right. But when you look at hydrogen, you notice there is a distinction. Hydrogen, we have 1 atom on the left and 2 atoms on the right. We have 1 atom of chlorine on the left and 2 atoms of chlorine on the right. So what we do, you look out for which value can help you balance the ones on your right hand side. And when you look at these ones, they're already 2. So that means you're going to come and multiply through by 2 and by 2. And when you add the 2 here, you notice that your equation will be balanced. Yes, Johanna, your hand is up.
Martha?
Yes, Shasova.
Now, on Johanna's equation, if you look at it, all of the compounds have, like the copper 2 oxide has 1, 2, then hydrochloric acid has 4, then copper 2 chloride has 2, and water has 2. She can simply divide through by 2 and should have the right answer. So sometimes when you balance like she has done, if all the numbers can be divided, then you go ahead and divide to simplify. So if you divide through by 2, she will get the right answer that we had expected.
Ali, thank you, Shasova, for that. Okay, Johanna, I hope we are now on the same page. Otherwise, thank you for your contribution.
Yes, teacher, but so it's wrong to have it in the other format.
It is because remember we are looking at the simplest ratios whenever you're dealing with these balancing of equations. So you notice that just say we have 2, 4, and you notice they are all divisible by 2.
Teacher Martha, your network was not clear, but Johanna
will still take you back to this. So it is always important to have the simplest ratio as your balanced equation. Johanna, are you there?
Yes.
Treasure, do you have a question or an answer?
Yes, teacher, I have a question. So it doesn't matter if it's only a specific element where we're supposed to reduce to, like if all the elements in the equation are able to be reduced, then we can reduce throughout.
Yes, if you're to reduce all of them, you should be able to reduce all the compounds in the equation. If you cannot reduce all of them, then they are not supposed to be reduced.
Okay, thank you, teacher.
Okay, thank you, Teacher Silverine. I think we can proceed. Anyone to go through with me the next example?
Nyakukiri, can you take us through? Nyakukiri, do you have a question or you want to take us through the Nyakukira, sorry, not Kiri.
Yeah, I wanted to answer.
You can go
on. Okay, so on the reactant side, magnesium has 1 atom, and then nitrogen has 2 atoms.
Helen?
Yes, then on the product side, magnesium has 3 atoms. And then nitrogen has 2 atoms.
Okay.
So to balance the magnesium atoms, put a 3 in front of the magnesium on the reactant side.
Okay.
Yes, and that was my final answer.
Okay, so do we all agree?
Yes, teacher.
Yes, teacher.
So now I can see that we've all picked up with the balancing of equations and
Yes.
Okay, that is good. So let's
Please
do
maybe
this.
we explain that part.
Somehow.
We'll get to it.
Okay, can we have someone explain is that Paula?
Yes, Miss, it is.
Okay, can we have someone explain for Paula what we've just done? Yes, Daphne, go ahead.
Sorry. Give us magnesium plus nitrogen. So on the other side, magnesium has 3 atoms, and on this side it has 1. So in order to balance, we have to put a 3 in front of magnesium so that the atoms are equal.
Okay. Paula, one thing you have to understand about balancing equations, you notice that we look at the atoms on the left-hand side, which we call the reactant side, and we look at the atoms on the right-hand side, which we call the product side. So when you look at magnesium, you notice, Paula, can I work with you? How many atoms of magnesium do we have on the left-hand side?
I think 6.
No, the original equation. I want to work with you from the original equation. How many atoms do we have on the left-hand side?
I think 1.
Okay. And then nitrogen?
1.
Now, Paula, I don't know whether you are able to get the recordings, but we said nitrogen is a diatomic atom. So it has 2 atoms, sorry, it's a diatomic molecule. It has 2 atoms in its molecule. So that means when you look at these 2 here, it simplifies that nitrogen has 2 atoms. That is why we have a 2 here. Is that okay, Paula?
Yes, Miss.
Yes, then we come to this side. When you look at the magnesium, how many atoms does magnesium have?
3.
3, good. And then nitrogen?
2.
Good. So when you look at magnesium on the left-hand side and on the right-hand side, is it balanced?
No, Miss, it's not.
So what do we do to make sure it looks the same as the one on the right?
I think you add 3 to the other side.
Okay, so Paula, what we do, we multiply by 3, not really adding, because when you add, you meet other equations where adding won't give you the same solution. So we do what we call the multiplication. You multiply by 3 to give you 3 atoms of magnesium this side. And then since you've made them 3, you'll come and write it in front of the magnesium atom. Is that okay, Paula?
Yes, Miss.
So when you look at nitrogen, for it, there are 2 atoms this side and 2 atoms this side. That means for it, it's already balanced. So you qualify this equation to be a balanced equation.
Okay, Miss, I have another question.
Yes, please.
Can there be a scenario where let's say magnesium is not a balanced equation, and then also nitrogen does not, the number of atoms are different?
Yes, it is very possible, whereby you have to balance them. And I think we've looked at that in some of these equations that we just done.
Miss, and when
notice
that happens,
when you looked at this,
when that happens, do you do the same thing you did for magnesium?
yes, that is what you do. You look out for a number that when you multiply it, it is able to give you the same atoms on either side.
And Miss, that's all you have to do.
Yes, and as you practice, you notice that you'll be able to identify which numbers can balance a given equation. But as starters, you may find that you have to do trial numbers. You try out with 2, find out are they balancing. Try out with 3 like that.
Okay, Miss, thank you. Now I understand.
Okay, welcome. Okay, girls, do we have any questions? Because our time is well and fast spent.
Shall the next number?
Should we do the next number?
Yes, teacher.
Isn't it already balanced?
Balanced already.
Okay,
It's already balanced.
Okay, so there are some other remaining numbers on this. Try them out. I think we'll have to post them on the Google Classroom. You'll try them out and then we'll see what to do in the next lesson. We'll find out what you were able to get. Is that okay?
Yes, teacher.
Yes, Miss.
Yes, teacher.
Okay. Jemima's hand is up. I don't know whether she has a question. Jemima? Okay, she has put her hand down. Okay, unless Mr. Anjuna or Teacher Sovereign have any communication, this will be the end of our lesson. Thank you so much, teachers, and thank you girls for attending.
Thank you,
Thank
Miss,
you,
for class.
teacher.
Thank you, teacher.
Welcome.
Thank you, teacher.
You're welcome.
Bye.
Bye.
Thank you, teacher.
Bye, bye, bye.
Bye. Thank you, teacher.
Teacher, please remember to put the recording to Google Classroom.
Bella, check your email. Bye.
Thank you, teacher.
You're welcome.
Bye, bye, bye.
Bye.
Oh my God. Oh my.
Nice afternoon.
You too. Food is not ready.
Come we eat.
Let me come.
Yangu, I'm finishing.